My name is Ben Follett, and today I'll be presenting our RISAConnection webinar about Canadian connection design with RISAConnection. Okay, really quickly, let's just look at a really quick agenda here. So we're going to walk through a variety of things, both in PowerPoint here and then also in a live demo. So the first we're going to walk through is talk a little bit about the available design codes and connection types that are available in RISAConnection. Talk a little bit about the comparison between AISC and the CSA codes, and then also how that kind of fits into and how we kind of look at the design procedure within RISAConnection with those differences, and what happens when one of the codes maybe assumes something different, or one of the codes doesn't explicitly have some rules to guide us on a particular connection type. Then we'll actually dive into some live demo and talk a little bit about the integration between RISAConnection and RISAFloor and RISA3D. And then we'll spend the majority of our time actually in RISAConnection, but I really do want to show off in the live demo how the programs in the RISA building suite all work together, because I really think that can be a really powerful tool rather than using RISAConnection only as standalone. So let's get right into it. When we look at the available design codes in RISAConnection, we do have 2 Canadian steel codes. So we have support for the CSA S16 2014 version, and then also the 2009 version. Now, we also do have some provisions out of the steel design manuals or the Handbook of Steel Construction or some of the different design guides that the Canadian steel industry uses. So it's not just from that CSA S1614. So we'll talk a little bit about where those different provisions, where those different specifications come into play as we talk more and more about different types of connections. As far as the types of connections are concerned, we really support both shear, moment, and brace connections, and we're always looking to improve and add different connections to our list. So if you're ever interested in a specific connection, if there's a connection that's not on this list that you'd like to see included in the Canadian connection design, please email us, send us an email into support@risa.com. And really that's the best way to let us know that, hey, I could really use a base plate connection, or I could really use some other type of connection, and then we can go ahead and develop stuff like that. But as far as the connections that are currently included in the Canadian version of RISAConnection, we have different shear connections, both column to beam and girder to beam, moment connections, all column, obviously, to beam moment connections, whether it's direct weld, flange plates, end plates. With a lot of those connections, you can also use HSS columns, and we'll look a little bit at that here in a bit. And then also some brace connections, whether it's a vertical diagonal brace like we see here on the right side, or a vertical chevron brace, or even a knee brace. And so all those different types of connections and all the provisions that go with those connections are included in RISAConnection. Now, one of the biggest things that I wanted to mention is kind of how the software deals with some of the changes or some of the differences between the American code, which is, us being an American software company, what we're really familiar with, and the specifications that are available for the Canadian steel market. And so just basically, if we look at the AISC code seeks to identify all the possible failure modes for a given member connection, meaning that every single limit state that could ever be calculated for a given connection is calculated, and we're going to check all of them. And that gives us a very exhaustive kind of check, or a very exhaustive kind of look at what is happening in that particular connection. Now, that's a little different than how the CSA spec or the CISC manual looks at things. So that in the Canadian steel connections, we really attempt to limit the number of failure modes which need investigated by ignoring conditions which are not to believed to be controlled. And so that's kind of the basics. So it's, I would say, a little bit more of a little less conservative, the AISC being a little bit more conservative. But that's really what we're looking at as far as the code itself. So the question then is, how is this implemented in RISAConnection? So what have we done in RISAConnection maybe to fill these gaps, or to compare these 2 different types of codes? And so our basic design procedure is that we use the design procedure based on AISC kind of methodology or thinking, but we modify that to fit the CSA S16 code provisions. So essentially, if there's not a specific CSA code provision, we would use a AIC formula but all of those formulas that generally for the standard limit states are replaced by their CSA counterparts, their CSA equivalents, and also the phi factors, those reduction factors are replaced as well. Now, one of the things that we're going to do, we are going to kind of stick to that AISC way of looking at things in the sense that we're still going to try to check all of the possible failure modes or limit states. So even if they're not necessarily required by CSA, we are going to check that. And that's, frankly, being a little bit more conservative and, not requiring any more work on your part. And we'll see that if you're not familiar with RISAConnection in a minute. Now, in the case where there isn't a direct CSA CISC equivalent, so when there's something that maybe the AIC code is specifying that we're used to doing, or the AIC code is used to doing, what we're going to do is, what we've done actually is in our development, used engineering judgment to determine the most relevant provision or cause from CSA to try to do those designs. And then if absolutely no guidance is given, if we're going to check something and there's no guidance based on the CSA code, we're going to use an AISC limit state check, but we will utilize those Canadian phi factors. So we're not going to completely keep it AISC, but and try to kind of fit it into the mold of those CSA codes so that we can get you the best design result as possible. Now the question is, where are some of the examples where this comes into play? So the first is in the calculation of rotational ductility. So that's not a calculation that's really included in the Canadian code, so we're going to use the provisions from AISC J 1.2. When you're doing lateral stability checks, or when the software is doing lateral stability checks, or creating or analyzing or designing whether we need stabilizer plates, we're going to use the manual from AISC, equation 10-6. Additionally, the Canadian code includes the instantaneous center of rotation methodology for calculating bolt group eccentricity. Our software, RISAConnection, also includes the elastic method for bolt and weld groups. And so that's not available in the CSA code, but we still are going to give you the option to choose that. That's a standard option, just as in the bulk or in the beginning code provisions or software provisions. So you can choose both of those. Also for cope beams, the CSA manual actually references the AISC manual. So we're going to just follow what the CSA manual tells us to do and go use the AISC manual for coping. For bolt material properties, we are going to use AISC provisions when you choose imperial designations. So if you do choose to use the metric ASTM, so like A325N-M, the metric version of that, we will then use some metric provisions and also metric bolt sizes and stuff like that, so that you can use all of that, so it kind of equates to what you're used to in the CSA code. Finally, for end plate moment connections, there's not a lot of direct guidance for that in CSA codes, so we are going to use the AIC design guides number 4 and number 16 when we do the end plate moment connection design for the CSA code. Also, in addition to, like I mentioned before, some of the other limit states that fit for those particular connections, we'll use those in addition to those design guides. Now, one of the things that the AIC doesn't explicitly use, that's one of the big differences that we found between the AIC and the CSA code, is the weld strength reduction factor in the CSA code. So the Canadian code then reduces the strength of some of the weld segments by this factor MW, which can be as much as 15%. And so obviously that's pretty significant when you're looking at the design of something. So in our case, what the software does is identifies weld segments where the value of MW is going to be less than 1. And then what we do is conservative, is we reduce all of the weld segments in the entire connection by 15%. So we're not looking at kind of individualized weld segments. We're basically saying, okay, if we find that MW is less than that 1%, we're going to conservatively reduce everything by that 15%. So you may not get results that directly match the CSI capacity tables for welds and RISAConnection, but you will still get a result that is, at the very least, conservative in its design. The other thing, like I mentioned before, that I wanted to mention is how RISAConnection looks at HSS column checks in moment connections. And so we are going to use the CDEC design guide number 3 for rectangular hollow sections, specifically this table 7.1. And so I didn't include the table, but what I did include here, just kind of for our benefit, is this range of validity. So basically, that we can only use this table, we can only do these things when we're within this range of validity, and that's this range of validity here. So basically, when we meet these provisions for tension, compression, aspect ratio, the different plate elements, and then angles and yield stresses, when we're within those limits, then we can include these HSS limitation checks, and we include these actually in what we call an HSS limitations and limit state. And so these checks are stuff like wall slenderness, material, the ductility, the connection width ratios, and then the aspect ratios. And you can see this is an output directly from RISAConnection. You can see here the reference of the code there, and then all those checks that it's doing, based on that code. Now, the last thing before we go ahead and jump into a live demo that I wanted to mention was the integration. And you may or may not be overly familiar with the integration between our software programs, but really, RISAConnection works within the RISA building suite with the other RISA family or softwares in our kind of RISA software family. And so it's going to be able to directly send information, and we'll see that between RISA 3D and RISA Floor, or RISA Floor to RISAConnection, RISA 3D to RISAConnection. So you're going to be able to kind of do your entire building design. So in RISA Floor, we would start our gravity floors and kind of model on a floor-by-floor basis for a large building, transfer that information maybe to RISA 3D to do a lateral analysis, and then maybe transfer all the information then from that point from Floor and 3D into RISAConnection for doing connection design. And then we can even send that information back, the designed information back from RISAConnection, and show that on the model in RISA 3D. And we'll walk through that in a live demo here, but I wanted to mention that integration before we go ahead and saw it live. So I'm going to go ahead and jump into RISA Floor here. Hopefully you see my screen. We've switched over to looking at RISA Floor here. And we just have this pretty simple building. So I have just two very basic floor plans, basically a roof and a lower level. And we've got some different beams modeled. We won't spend a lot of time discussing the modeling or the setup or the information here in RISA Floor, but the first thing that we wanted to look at here is looking at the connection rules spreadsheet. So if I open up the connection rules spreadsheet, you can see all the different connections that are available in RISAConnection. Now, some of these aren't available, like we discussed, for the Canadian connections, but we're going to go ahead and use the ones that are available. One of the things I do like to mention here in this list is, there is a simple, for instance, a simple column beam single angle shear connection. You do have some options that you can input. How does the beam connect it? How is the column and girder connection? Is it bolted, right? Maybe you want one of the types of connections in some space to be bolted, but you want another to be welded, or you want another to be bolted, welded. What do you do in this grouping, if you only have one option? And so in that case, you can always add additional lines to this spreadsheet, basically additional groupings, and just basically say, hey, this label is going to now be column beam single angle bolted, and this one's going to be single angle shear welded, right? And you can switch those and make those, update those the way you need to. Now I can go ahead and actually turn on my connection rules. I already have a few assigned. So if I zoom in here, we can see I've assigned maybe a couple moment connections or a couple column beam shear tab connections. What I want to do is I want to assign some of the connections in this particular model for just our gravity members, because our gravity members aren't going to be transferred to our RISA 3D model. And so we'll be able to assign connections for the lateral members in RISA 3D. But in this case, I'm actually going to transfer everything to our RISA 3D model just so we can see everything. But maybe I'm going to choose to use my gravity members here. And so I can do this in a few ways. The first is I could simply double click on an individual member and come to the general tab and see here in our connections, just choose the connection I want to use, right? That's a bit time consuming and tedious. So what I'm actually going to do is open up our graphical editing toolbar and come into our draw and modify beams. And I'm going to choose to modify properties. And I can choose to enable the modification of the properties for RISAConnection. So basically those connections themselves. So I'm going to turn on a girder to beam single angle connection. And I'm just going to go ahead and choose both of these. And I choose that I want to use both at the ends. And I'm going to choose to add them by clicking on beams individually. And I'm just going to go ahead quickly and just assign them. So I can see that I'm getting that information just as I'm clicking on that member. So I'm assigning those connections. So now that I've assigned those connections, we can go ahead and actually, I've got load combinations already created here. So I'm just going to go ahead and really quickly and run the model. It's just running an optimization here, but it'll just give us our basic information. But at this point, we did our very basic floor design. We're ready to go ahead and send this model over to RISA 3D. So I'm going to choose the director in the top right-hand corner here. and I'm going to choose RISA 3D. Now the director allows us to navigate back and forth between the different the different softwares that we're using. So when we move back and forth between RISA Floor and RISA 3D, the first thing we're presented with is the ability to kind of change or add our lateral loads. And so in this case, the first dialog box that pops up is our wind load dialog. And so we can see here, we can choose our code, we can choose our reference velocity pressure, some of the different factors here. We can choose to click calculate load, and it's going to go ahead and actually apply, these pressures and these forces on the given member. And so once I do that, I can go ahead and click OK. The next I'm going to be presented with is, in a similar fashion, the seismic loads, right? And so I have the seismic information, and we can set this in any way we want. You could ignore this and assign your own wind and seismic loads in RISA 3D, but I'm going to allow the generator to do the work for me in this case. So this is as I want it here, so we can see the load it's going to apply on those different diaphragms, and we can go ahead and click OK again. And so RISA 3D is just going to launch. So it's really this kind of interactive, kind of one model-like experience where we're just, I don't have to save something and open something else. It's just kind of creating the model file, and it's going to open everything in RISA 3D. And so now I have my RISA 3D model open. We can see it's the same file. I did bring everything over so that we can see it all in RISA 3D. And so we can see now, if I open up the connection rule spreadsheet, we have a similar connection rule spreadsheet that we did in RISA Floor. So again, this idea that everything is kind of the same in RISA Floor and RISA 3D. You're not making a lot of changes. All this information is tracked. The other thing that's really nice is the loads are all tracked, right? So these dead loads that we applied, these area loads that we applied in RISA Floor are available to us in RISA 3D. And so you can see all these dead loads tracked. You can see load combinations information is tracked, right, if we wanted to. But we're looking at dead loads, live loads, and then we can actually go ahead down here and we can look at our wind loads, right? So our wind loads, our wind point loads are applied at the center of gravity of this member, right, or of this structure. And so in this case, we have this L-shaped structure. So the bottom level, we're a little bit outside the structure itself. So we have our wind loads applied, and then we have our earthquake loads applied. And so all of this information is applied so that we can see exactly what is going on, right? So there's no guesswork as far as what RISA is applying for those loads in this case. Now we can go ahead and add additional connection types, right? So we had some of the connection types already added. I can go ahead and turn them on so I can see our connection rules. And so we can see we brought across all of our gravity beam connections. So those already came across. I've already added some of the moment connections, but in this case, what I actually want to do is I need to add some bracing connection types in the middle along this line here. So what I'm going to do, just so I can really get in there to select to see what I want to work on, is I'm going to go ahead and turn everything off on the model. So deselect everything. And then I'm going to get a top view of the model. So here's a top view. And our brace is along grid line 4 here. So I'm going to go ahead and use just a selection tool to grab that entire brace line. And then I'm going to use the lock tool to lock out only that group of members. So basically seeing that I've only selected that particular set of members. So now I can go ahead and say, I want to apply my diagonal vertical brace connection. Maybe that's what I wanted to do in this case. I want to apply a diagonal vertical brace connection to these vertical braces. And so we're going to use the same kind of graphical editing that we did before in RISA Floor. So I'm going to come to our beams and choose to modify properties. And again, come and choose that I want to modify the properties of the start and the end node here. Now, in this case, I'm only going to do the start. I only want to modify the property or add the vertical brace connection basically at this beam to brace connection. And so depending on how you've modeled this is really going to depend on if this gets applied in the right location. And so I'm going to go ahead and turn on our diagonal vertical brace connection here and click apply. And if we go ahead and start working this, we can see actually I drew this, my eye end is down here, right? And so I drew this in this fashion. I can go ahead and begin to start modeling this, right? So I'm adding these members. So to the eye ends of that member, I'm just going to go ahead and recall the dialog and switch this here, diagonal vertical brace, and go ahead and add this to the J ends as well. So basically adding that for everything there. So I can go ahead and turn everything back on here, and we have what we need here. Now, one of the things that we need to do is we need to we must include the beam as part of the connection here, right? So this beam has to be included as part of the connection because this really is going to be designed as an assembly. So if you don't, because the vertical brace connection actually checks this beam connection here, so it checks the clip angle or the shear plate or the welds or the bolts into that connection there. If you don't include that and you would say, hey, this is going to be a diagonal vertical brace, and then this is going to be a column to beam clip angle or something like that, you would actually get an error from 3D RISAConnection that would say, hey, that we've got this invalid connection type, basically this mismatch of connection at a given node, and so you have to go ahead and make some revisions there. Okay, the next thing I want to go ahead and look at is, let's go ahead and just open up the material spreadsheet. I have some AISC materials in here, or excuse me, I have some IBC materials in here, but I also have a few Canadian materials here. And a lot of that is dependent on, obviously I use AISC more often. That's my base code for analysis, but this is all based on your defaults. And so in this case, I've added these two different steel codes. You can go ahead and install these different things during setup. There's different, default tables for the steel codes or the steel materials that you can go and modify and update based just solely on a spreadsheet that's saved in our databases. So you can make all those changes as necessary. Now I need to go ahead and look at load combinations. Before I can do an analysis, I need load combinations, obviously. And so I don't have any created. And so I'm going to use the load combination generator. And so in this case, we can choose the gravity, wind, and seismic combinations that we want to create. And so I'm going to go ahead and just use our, choose the Canadian connections here. We'll just choose NBC-15 Ultimate. We'll just use Ultimate connections in this case. We can choose what we want to include as far as the connections go, or we can just go ahead and click Generate. We'll do the same for wind. So wind, we'll just do X and Z, generate those, and then for seismic, switch also to X and Z, and we'll generate those. And so when we're done here, we should have, 26 different connection types, or excuse me, 26 different load combinations. And so we can see all the different load combinations here in the combination space that's going to actually be run for an analysis, from an analysis perspective. The first thing that we also need to do, though, is we need to turn on P-delta analysis. So I'm going to go ahead and just select everything in this column, and I'm going to right-click and use fill block and just click in Y here to run all of that for P-delta analysis. Now we're requiring P-delta analysis to get a code check. You can actually turn that off in the application settings of RISA 3D, but in this particular case, we want to include the P-delta analysis. The other thing we can do here is that we can go to the Design tab and we can see the different combinations that we would use for various materials, right? So whether it's hot rolled or cold form or wood, in this case, we also have connections, right? Maybe you don't want to use all of your design, or excuse me, all your design combinations for connection design, right? Maybe you want to pick and choose what are being used. So you can do that. You can, turn on and off different ones so that you don't have to include those in the connection design. It's also possible, just for your reference, it's also possible to make modifications to the seismic and wind loads here just by going into the insert. So you don't have to actually go back into RISA Floor to make these changes. You can actually go into the insert, drop down, and access the wind and seismic load generators to see that. Now at this point, we have our load combinations here. I'm going to go ahead and actually choose to solve a batch in an envelope load combination. So the idea behind this is that we want to get basically individual load combination results so that we have all the different combinations, but we also want to solve this in a batch, right? We want to basically say, hey, we want to understand where the worst case axial is in a beam, where the worst case moment is in a beam, what's the worst case shear. So we want to understand the envelope, but we also need to understand that, hey, it's not going to be in the same combination, and so we need to be able to look at all of these different things together. So this really allows RISAConnection to then evaluate all the possible load combinations and maximum reactions in order to provide for us a design that is according to what load is controlling, so giving us the most accurate design. So I'm going to close this out, and I'm actually going to jump now into the director again. I'm going to switch into RISAConnection. So again, it's going to open up and it's going to include the results, or it's going to include our model here, and we can start to go ahead and work through things. So we can see here right off the bat, we can see the different groupings that it found for those connection types. So the different groupings that we had established: column beam direct weld, column beam flange moment plate, our shear connections, our brace connections, all of that information is included there. Now, one of the things to know is that RISAConnection is actually a separate file kind of structure from RISA 3D and RISA Floor. So with that, what is possible is that this gives you the ability to maybe have one engineer working on the connection design while the other engineer is working on the superstructure. So maybe you have a connection design engineer that's working directly with the fabricator or something like that during a later design phase, and it makes a lot of sense for those to be disconnected. You can do that a little bit maybe after you make this one transfer. Let's go ahead and, before we get into the design, look at the settings here. So under the Solution tab, we can see our code spec that is chosen. So this is locked. This is based on that spec that we chose, or the design type that we chose in our RISA Floor and RISA 3D model. So that's locked to us. We can also see some of these options that we mentioned in the beginning in the PowerPoint presentation about some of the settings and the options that have available to us. So bolt group and weld group analysis methods, some of the options for rotational ductility and weld-based material thickness, type, all that stuff, we can choose to turn on and off. Some of this is grayed out because it's really specific to AISC, but we have all these options to make these changes. We can also set up our units. So right now I'm just using the standard metric units. You can change your units to whatever you want. If you want it to be in, millimeters or centimeters for dimensions or length, you can make those choices based on what you want it to do. But now this is the basic interface of RISAConnection, and I really love the interface of RISAConnection mainly because it's super intuitive, right? You get very clearly what's going on. You can very clearly work through the different connection types or work through the different limit states, and we'll see that here in just a second. So to start this kind of process, I'm going to go ahead and solve the entire project. So I'm just going to click the Solve Project button, and it's going to calculate just based on the defaults. So there's defaults that we can set, or there's defaults that come right out of the box, just trying to figure out what the connections are and how they work, right? And so this isn't doing an optimization. That's really difficult in connection design because you can, change the bolt size or change the bolt, locations, or change the weld thickness, or, change from a CJP to a fillet weld. You can do all these different things, which can ultimately solve your connection problems. And so you really have to be able to get in there and tweak exactly what you want to tweak. Let's go ahead and start by opening up one of these connections so we can kind of look at the basic features and navigation of the interface. So I'm going to go ahead and open up the column beam direct weld connection. So you can see we have these two connections, and I'm going to go ahead and open up this first one here. So we have this first connection here. So we can see first off that we've got this really nice kind of 3D interface that we can kind of navigate around, and we can see exactly kind of what we're looking at. We can turn different things on and off, so we can look at different views, right? So we have those preset views. I like opacity, in the case where we've got a lot of stuff going on, maybe in one of the brace connections, we have an opacity so we can actually see some things. We can also turn on and off some different, kind of viewing setups and stuff like that. The biggest and best to me here, though, is the 2D views. And so in the 2D views here, we can actually see the dimensions listed on these 2D views. So in this case, we have a side view and a top view. Now there would be some other views, a bottom view and some other side views and more complex connections, and we'll see that. But really this allows us full interactive kind of modification with the model. So for instance, if I go ahead and select, in this case, this dimension right here, which is this 45 millimeters, if I select that, it selects that same or that similar dimension or that similar property in the properties here, the connection properties. So that vertical base, or excuse me, that vertical plate position, I can go ahead and change that, or I can see exactly what that is, right? If I want to click here, I see the longitudinal spacing, I can see the column beam clearance. So all of these things I can see, we can change the cope size and stuff, so all of this stuff I can see so that I can be able to kind of interactively move back and forth with this. And the same thing goes for the top on this. In this particular case, we're just doing a direct weld. There's not a whole lot on the top, but we can see exactly what we're looking at. The other part of this is the reports, right? So the reports give us a really great kind of look at exactly what's going on in this particular model. And so all these reports are expandable. So if I look at geometric restrictions or whatnot, we can see here, I can check it's checking our bolt spacing. If we go ahead and look at I don't know, let's look at bolt bearing on a beam web, we can see the equation that's being used. We can see exactly the clause that's being used from the code, from the CSA code, which is listed up here. And then we can see all of the different kind of portions of that limit state filled in. Okay, so how did we calculate, BR inner? How did we calculate BR bolt? And what is that, frankly? Sometimes, especially for a younger engineer or someone that may not be as familiar with the code, they may need this information to figure out exactly what's going on. So having all of this information is really great. The other thing that this really gives us is it tells us exactly why things are failing. So if we come down here, all of these are passing, which is great, but then we have a failure down here. So we have a failure in column web yielding. And so not only does it tell us, hey, it's failing based on this clause, and so we can see what we need here. So we have a required amount of 369.25 kilonewtons, and what we're giving the system is 281.19 kilonewtons. So for a unity check, basically we're 31% overstressed. And so what do we need to do with that? Now, obviously there's a bunch of ways to solve the problem, but in this case it's telling us, hey, either add a column transverse stiffener, or you're gonna have to modify the column size, right? You're gonna have to basically thicken the web of that particular column. In this case, because our model is tied to our RISA 3D or our RISA floor model, we're not gonna be able to modify the column, so we can't change the column size because it's based in the model there, but we can certainly add column stiffeners. So if I come back to the 2D view or the 3D view real quick, I can come into our properties here and look at transverse stiffeners, and I can say, yeah, I want to add transverse stiffeners. So it's going to go ahead and add those transverse stiffeners. Now, in addition to those stiffeners, it added obviously all the properties for the transverse stiffener itself, right? So we have, the size of the stiffener. So what's the thickness of the stiffener? So maybe we want to make it 12 millimeters, right? So thicken up our stiffener a little bit. What's the material of the stiffener? We can see, maybe we need to change the material. Do we want the stiffeners to be full depth? Obviously the width and the depth are tied to the size of the column, but we can see all of this information. Now, since we made that change, we lost the result of our column or our check there. So we can go ahead and choose to rerun that particular connection. And then we can go back to the report to see, okay, what's going on here? Why are we failing? So now it's, we're failing in a weld limitation, right? So we have a fillet weld size that we have, and maybe we need to go ahead and change our fillet weld, right? So, I can come in here to, our column weld and, change our column weld, and then, rerun it and kind of bounce back and forth between things that are going on here to solve our overall problem. And so we can really see exactly, what our solutions are, what our problems are, and really decide, how we want to solve this particular problem. And so this is really an interactive procedure to kind of figure out, okay, what is the problem? What are the options I have to make these changes? And then how do those changes, ultimately change my design and ultimately give me the design that I want? Okay, so we looked at the column beam direct weld connection. Let's go ahead, and I'm going to go back to the kind of overall system here. And let's go ahead and open up one of the column beam flange plate moment connections. So let's go ahead and open up this guy here. So we have this flange plate moment connection, and we can go ahead and let's choose to open up this first one here. So this is our first connection here. So we can see it pretty plainly. There's, again, not a whole lot going on, but one of the nice things about RISA connection, and remember we talked about the type of analysis that we ran that batch analysis, which gave us the envelope results, but also gave us each individual load combination results, is we can see exactly all of the load combinations. And you can see, even though we didn't do an import explicitly from RISA floor, right? We didn't actually click the director button to go from RISA floor to RISA connection. All of the RISA floor load combinations that were created are available to us. And so in this particular case, the controlling connection or the controlling combination here is from 3D. It's load combination number 19, and it's from the code NBCC4DA, right? So that's right out of the code, telling us exactly what is controlling here. And so now we can see also up in the Project Explorer, okay, it's again load combination number 19, and we have a max unity check of 1.5 for that failure. So if I go into our reports, we can start to see kind of what's going on here. So we've got some issues in bolt shear and bolt bearing at the flange plate. So we've got an issue with our flange plate weld, flange plate. So really we can see that it's all the issues are with our flange plate. So let's go ahead and look at our 2D views to see if there's anything we can recognize with the flange plate. So maybe look at the top view. So maybe the first thing we want to do is maybe I need to change the size of this plate, right? This plate obviously can get a little bit bigger. So I'm going to go ahead and select on the width of this plate, make this maybe 200 millimeters. So that makes our plate a little bigger. We can also change the thickness of this plate, maybe to 12 millimeters. And we can kind of play around with the bolt gauge. Let's make the bolt gauge 120, right? So we've kind of making some nuanced changes to this. The other thing we can do is we can change our bolts, right? So let's go ahead and look at our bolts for this particular member. So let's look at our moment beam bolts here. So we've got these bolts, and remember, like I said before earlier in the presentation, we have our imperial sizes, but we also have these metric bolts. So I'm going to switch to the metric bolts here and choose a different diameter of bolt. So let's choose a 22 millimeter bolt, right? So we have a little bit bigger of a bolt, a little bit more hardy, so that we can maybe get our design that we need to. And so if I go ahead and calculate now this connection, so we've done a bit better here. We're at a unity check of 1.1 now. So if we jump back to our reports, we can see we solved a lot of the flange plate problems, but we're still with a problem with some weld strength at the column and some other flange plate issues. So let's go ahead and change our weld size, right? So if we look at our moment column weld size, let's jump up to 5 here. So again, we're starting to solve some of the problems. Maybe we need to make maybe we need to change the thickness of our plate even more, right? But the idea here is that we can jump right into this and say, okay, we understand kind of what's going on, and we're changing what's required here to make this pass, right? So I really just needed to thicken up my plate. We needed a bigger gross area so that we didn't get that tensile yield failure anymore in this particular check. Now, one of the nice things about this too is that, let's say that you went through this process on this particular job and you said, okay, this is probably what I'm going to want. I'm going to have a lot of moment connections here, and this is the moment connection I'm going to use. When I come back and forth between RISA 3D and RISAConnection, I want this kind of standard to be saved. Maybe I'm going to add new connections and stuff like that. I can also save this as a default, right? So when I save this as a default, these default settings for this particular connection grouping, so the column to beams flange moment plate connection, is going to be saved. And so the next time that RISAConnection brings something in, and maybe a new connection, and it starts to design that, it's going to use these base settings. So we're going to have a 200 millimeter width plate, a 13 millimeter thickness plate. Our bolt gauge is going to be this. Our bolt size is going to be this. So all those things are going to be saved there. So you don't have to do that over and over again. Now, again, let's go ahead and jump back here. And I want to look at one of the shear connections. So let's go ahead and look at this girder to beam single angle shear connection. And so when we open up the girder to beam single angle shear connection, we have, really in this particular case, it's telling us that everything has passed, that we don't really have any issues going on. We're not running into anything. Maybe let's go ahead but we can, if we want to, make kind of bulk changes, right? So let's say that we were getting a failure on one of the connections, but we didn't want that connection to be different than all the other connections, because it shouldn't be, right? It's a gravity beam member. We can actually come into the bolts here, and we can say, I want to change the bolts for the entirety of the group. So let's say for our girdle bolts, let's make those 2, and for our beam bolts, make those 2, right? So let's just, we want a tiny little angle here. And so if we go ahead and solve the whole group, we could see if this is going to work. Obviously, in this case, it's not going to work there. And, so maybe we could go ahead and look to see, what's the problem. Maybe it's the beam bolts and not the column bolts. So we can kind of make group changes here so that we can just do, the totality of this analysis. So really a three bolt connection for this particular type of member is really what we need. So if we jump back into our groupings again, maybe we can look at, I have some welded shear tab connections. One of the things I also like to look at here is that we may find an instance, like in this case, where we're getting a connection that may fail, but really the reason it's failing is not based on the fact that it's any limit state, but it's really it's a geometry thing, right? And so in this particular case, the standard setting was a 4-bolt connection, but probably don't need 4 bolts. And so we can actually go ahead and say, I'm going to make this a 3-bolt connection and, rerun this, and we shouldn't get any failure now. Our unity check is now not based on geometric restrictions, basically the fact that the plate was too big and it was running into the flange of the beam, but on, some other controlling aspect, controlling limit state of this particular design. Okay, let's go ahead and look at, I want to look at the brace connection because those seem to be kind of the most fun. They've got the most going on. And so we're going to go ahead and look at this second one here. So this particular brace connection, you know, it's a weak axis. It's framed into the weak axis of a column here. So we've got girder, or we've got plates welded to the gusset here. And so we can see kind of all the different views. And this is where I really think the 2D views really come in nicely. So you can see in this 2D view all the different options. And even if I make this a little bit smaller, we don't need quite as much there, but we can see all the different things that we have available to us here. So first thing, you can see kind of this green line here. This is actually the Whitmore section being calculated and shown graphically. So we can toggle on the view of that. But when it's green, it's within the normal region and within the region for design, and it's sufficient. If you would actually see that marked in red, it would tell you very explicitly that you have a problem with your Whitmore section and you need to make some changes. In this particular item, in this particular case, you know, we can see here the load combination 16 and the unity check is 5.0. So we're getting quite a bit of failure in this case. And so let's go ahead and look at our reports. We can see that on our, because there's so many limit states, there's so many different pieces and parts. Remember, this is an assembly that's also not only including the brace connections, but also including the beam connections as well. All right, and so if we go ahead and see this, okay, you know, the beam to column connection's fine. The top, basically we have issues in the top gusset and brace connection, and that's a geometry issue, geometric restrictions at the gusset, and also a bottom gusset at brace connection, that's bolt bearing. And so if we go to top gusset first, we can see in the failure here, okay, we've got an issue with max edge distance, really just the edge distance calculated from clause 22.3.3. Basically, here's our max edge distance that we have. Here's what we need. You know, we need to make some changes here. If we go ahead and look at our bottom gusset plate, basically we've got a whole bunch of problems, being not only being that we have geometric problems, but we also have some problems with bolt shear, bolt bearing on the brace, on the gusset, you know, so on and so forth. So if I go ahead and jump back into the 2D view, I'm going to start to make a few changes. So the first thing I'm going to do is I'm going to kind of move out this brace by kind of extending the work point. So I'm going to set this to be from 650 to like 850, basically just kind of stretching out the work point of that particular member. And I'm going to do the same at the bottom here. I'm going to make this, let's say 1150. And so a lot of this is a little bit of trial and error, trying to figure out kind of where things fit and how they fit. And so if I go ahead and rerun that connection now, we're still getting kind of the same failure. Still getting the failure in our bolts, but let's go ahead and look at our reports now. So if we go back to our summary, we're still getting our geometric restrictions, so that's okay. And now, but we're still getting our bolt shear problems. So let's go ahead and say, okay, let's change, we need to do some updates, we need to change our bolts. So I'm gonna go ahead and click on our bolts here. And the first thing we wanna do is, let's say, let's look at our bottom brace here. And I'm gonna go ahead and make, these are column bolts, we don't want our column bolts. Let's change our bolt size here. So let's select our bolt size here. And we're using a standard hole, which is fine. And then let's look at our bottom brace. Here we go, brace gusset bolts. So I'm going to change these to our metric bolts as well. So let's choose our metric bolts. Let's make our bolts a bit bigger. So it's 22. And just as I do this, I like to make changes. I like to make updates. So, okay, we went from a unity check of 5 down to a unity check of 3.7. So we're starting to make some changes here. So that's starting to work a little bit better. Let's go ahead then and see, you know, are we still failing in bolt and gusset? So maybe we need more bolts, right? So maybe that's the problem, right? We need more bolts in this particular gusset. So maybe we need 6 bolts, right? And if we need 6 bolts and then we need to run the connection here, you know, we can start to, you know, kind of work our way through the different things. So now we're not failing in bolt shear anymore. We're not, our worst case failure is not in bolt shear anymore. It's in, you know, our gusset plate compression. And so maybe we need to change the size of our gusset plate, right? So we can really start to kind of hone in on this. So if we look at our gusset plate size, let's see. Let's look at our gusset plate. Our column bolts are good. Let's go back to general and we can see our gusset. So we can maybe change our gusset size here. You know, we can select these lengths and stuff like that of our gusset and start to make changes to our gusset, or maybe we just need to, frankly, up the material of that particular gusset so that we start to get less and less and less. Now, ultimately, again, we can kind of work our way through this entire thing. We won't spend the entire time going through this, but we can kind of work our way through this. The last thing I wanted to look at, though, before we kind of look at kind of how this all works together, is I did want to look at the HSS connection here. So let me open up this HSS moment connection. We're not going to go into this into great detail, but I wanted to, let's go ahead, see, we can do an HSS moment connection. If I go into our reports here and we look at those HSS limitations, like we saw before, it is using that code. So we are seeing that provision, or that design manual, if you will, design guide, and that table 7.1 from that design guide being used. And so it's going to use all that and calculate, frankly, all of these different things. Now, again, some of these things, are all coming directly from that design guide. And so we're implementing things beyond the standard CSA code in order to, give you the most robust analysis and design that you have. Now, one thing I want to mention before we're going to go ahead and send information back into RISA 3D or create reports, one of the things you can do here is you can do what's called detach, right? What we've been doing this entire time has been looking at looking at the connection of RISA 3D, RISA Floor to RISAConnection, right? So this kind of connected approach, this kind of one model approach where the information based on the loads, right? The load combination, and then here the shear and moments, all this information is kind of grayed out because it's coming from the larger model. If you wanted to, obviously you can use the entirety of RISAConnection standalone. In that case, really you'd have post-processed loads. Basically, you'd have loads that already have load factors in them, and you would apply, hey, here's my maximum shear load, here's my maximum moment load, and you'd be able to kind of do an individualized kind of connection design, kind of one-off, right, or a grouping of them. And for a lot of our customers, that works really great. But in this case, if you wanted to do the workflow like we talked about a little bit before, where we want to maybe say at a certain point, I'm going to have a superstructure model and then I'm going to have a connection model that's being used with my fabricator, well, you can do what's called detach. So basically, I can detach the project from the integrated model. When I do that, I keep all the connections, but I lose basically the link, right? I lose the linkage between that, meaning that if I make changes to the connection, I can't send that information back into RISA 3D. Or if I make changes to the columns or something, they're not going to get updated, into the RISAConnection model because we broke that connection. Now, the last thing I want to show in RISAConnection is the ability to create reports. So if I click Print Report here, we are brought into our report printing interface. And so within this, you can choose what to include in your reports. So include all 2D views, all 3D views. One of the things I always caution people is you can choose how much of the limit states you want to include. So in a lot of cases, you don't want to include the fully expanded view because that's going to give you all of these limit states expanded, which is going to give you pages and pages and pages and pages and pages of output. And it's just going to take a while. So I usually use either the as seen view if I want to show something very specific, or the fully collapsed view. And then we can choose, what we want to send in there. So maybe I'll take, I'll add one of these shear tab connections in here, and then maybe we choose this direct, one of these direct weld connections, right? And so we've got a few connections here. We can choose, do we want to print the governing load combination, or do we want to select a specific load combination? That's completely up to us. And then in this case, I can just go ahead and click to generate the report. Now, in this case, you could either print it, or in my case, I'm going to go ahead and print to PDF. I'm just going to create a Bluebeam PDF for it. And it's going to give us the, it's going to launch for me after it creates these individual reports and the pages and pages of reports, because it's giving me all this information, including the global description and the global solution. It's going to go ahead and give me my PDF, and it's going to allow me to save my PDF. And then the nice thing about this, so I think I can, overwrite one here. I have one on my desktop. I'll just call it and overwrite it as my connection report. I think the nice thing here is that we can then include this into our reporting for RISA 3D, right? So we can take this and say, okay, we have this created for us, and we can review this here in RISAConnection, or see this in Bluebeam, and actually open to my other screen. So let me just pop it over here. And let's zoom in here. So we can see, all the things are included, right, with our little picture, a little description here. So we can see the pictures that are coming from this particular connection itself. And so we can include that, we have this here, but we can also include this in our 3D report. So if I go ahead and close this out, I'm going to go ahead and I want to export all of my findings, everything I've done so far. I want to export it into RISA 3D. And so I'm going to click export, and it's going to kind of build the RISA 3D model, if you will, and it's going to go ahead and open up, back up RISA 3D. So I have RISA 3D open already. So if I jump back into RISA 3D now, we see the connection design results. So it tells us, okay, at a certain label, so our purlin or our member, the I and the J node, what's the connection rule? Is it passing or failing? What's the max unity check? What's the governing load combination? And then what's our limit state? So in the case where it's failing, obviously it's not governing max unity check. It's just telling us we have a failure in this case. And so, we're getting, in this case, it's because of geometry restrictions. So we can see exactly kind of what's going on. But we can also go ahead and see this graphically. And this is where I think is the biggest advantage. So we turn off rules and we turn on results. And so we can see our connection results right on our model. Let's turn off the node labels here so we can see things a little bit better. So we see exactly what's going on here. So there's really no guesswork. You can see exactly, because I know sometimes, especially when you have a really large model, you may lose kind of, okay, I've been working on this connection, but where is that located on my beam? Or if I make a change to that, especially if I maybe break things, how does that change affect the connection design that I've done in this case? So it's a really nice tool to kind of be able to kind of round trip, if you will, the workflow from RISA Floor to RISA 3D and to RISAConnection. And you can do the same thing. We could send this information for the gravity members. If we were just doing our gravity members in RISA Floor, that information can go back into RISA Floor as well. And so that's that's really kind of the entirety of what I wanted to go through today. And so we have obviously talked about kind of the basics of the connection design procedures for Canadian connections, kind of how they relate to the AISC design procedures as well. Talked a little bit about how the RISA building suite between RISA 3D, RISA Floor, and RISAConnection work together to design connections and give the information, load combinations, and other things to the connection design software to do the connection. And then really looked at the super interactive and intuitive interface that RISAConnection has to be able to allow you to design connections for the Canadian provisions. So there is a demo of RISAConnection. So just like we have demos for all of our softwares. And so it's a full demonstration version of RISAConnection. The only limit is we do limit the steel and the weld materials. So basically, you can still go through all the provisions. You can do any type of connection you want. You can see all the limit states. But really, the idea of changing that is we don't want people to do actual design with our demo version. But there's no time limit on it, so you can really check out exactly what it's doing in its entirety for that. So if there are any other questions, feel free to email us at support@risa.com, or you can email me directly at benf@risa.com. We're happy to answer whatever questions you have. If you're interested in purchasing, or if you're interested in just learning more, send us a question, and we'll be happy to do what we can to answer it. And I thank you for joining us, and hope you have a great day. Thanks very much.